are not here. So today we mentioned that we're looking at a new topic, which is the volume topic. And John, you mentioned something about getting a formula list to help us.
Mm-hmm.
And you are correct, because if you look at the formula list, that this will be available to you during any exam or any assessments that I've got. Yeah, so basically anything to do with NAT5, you get this formula list, and you could see straight away you've been given the formula for the volume of a sphere, the volume of a cone, and the volume of a pyramid. Okay. So first one is 4/3 or 4/3 pi r cube. Volume, that's why we get an r cube. For the cone, it's 1/3 of pi r squared times h. So it's r squared times h, not r square or r to the power 2h. It's r squared times h. And the last one, 1/3 of a being the area of the base of your pyramid times h. Okay. So how do I know that A is an area? Because the only time you're going to get a volume, if you time a centimeter square with a centimeter, that's when you're going to get a centimeter cube. And that's why this A stands for an area. Okay, so let's see the first slide. So the first thing we're going to learn about is we're going to calculate the volume of any prism given its area. So if we can do that. So to define a prism is just a solid shape with a uniform cross section. So I can have a circular prism. That's what they call a cylinder, if you remember. So a cylinder is a prism, but it's called a circular prism because you can see that it's made of few circles that you can pile one on top of each other. Okay. So this is probably more like what you would call a prism when you went to science and had a glass prism where you had a triangular shape, especially when you wanted to look at the color of the rainbow, for example. So whenever you were passing like a white light through it, you could see by refraction, you had a set of all the rainbow colors. So if you get a chance to go into a science lab one day, you can always ask a physics teacher to show you how to refract a white light into all the colors of the rainbow. Okay, and you probably know that the rainbow is just made of a straight white light of the sun crossing through crossing through a rain droplet, and that's why we see the rainbow appearing. It uses refraction the same way like a science teacher would show you. So in this other prism, we've got 1, 2, 3, 4, 5. So it's a pentagonal prism. The next one is just what we call a hexagonal prism. So I'm showing you these because in order to calculate the volume of a prism, what you do is you calculate the area first of the section that is uniform, the cross section, and you time it by the length of your prism, or the height of your cylinder. I'll show you some examples. Okay, so the formula to remember is when you calculate the volume of any prism, you need to calculate the area of the cross section and you time it by the length. Okay, so in our case here, the length for the cylinder is that height there. You just imagine if you had these circular shape piled on top of each other, you fill in the void there, the empty space, which is the volume, with just slices and slices, and that's how you do the slice times the height and gives us the volume. Here the length is going to be across there. The same for these two there. Okay. So now, if I ask you find the volume of this triangular prism, obviously this is not given in your formula list, but you need to remember the formula I just gave you there. So if you remember, area of the cross section times the length. So you've been given the cross section. What's the area of the cross section from what you can see here? 20 centimeters square. Yeah, time the length, which is 10 centimeter. Yeah, so now the volume is just 20 times 10, which is 200, and a centimeter square times a centimeter. This time it becomes a centimeter cube.
Sorry.
Okay, so that's where the cube is coming from. It's the volume. An area times a length give me a centimeter square times a centimeter. So centimeter square is to the power 2, centimeter and so on is to the power of 1. And you remember, you add the two indices, 2 plus 1 is 3, and that's where that 3 is coming from. Okay. So, this is revision. This is like NAT 4. So I've got, you can practice on these 3 if you want, just to show you quickly. So you've got 3 shapes. One is a cuboid, the other one is a triangular prism, and the last one is just a hexagonal prism. So this one, they told us it's a square base prism. So you've got 24 centimeters square.
Yeah.
So root 24.
So this is something they wouldn't share with you in the formula list if the question was to be on the volume of a prism.
Yes, so basically a question that could appear would be, for example, you've got I don't know, a cone or something like this.
Yeah.
And on top of it, you've got another questionnaire, like you've got a pyramid. So then they ask you to calculate the total volume.
Mm.
So this cuboid shape here, they expect you to know how to calculate the volume. If the base is 24, they'll give you the height as well. So this is where you would need your formula list to calculate the top of it. So that could be like the tip of an arrow, for example. Yeah.
Yeah, to say what is the.
Yeah, what is the total volume? So if this arrow was made with, I don't know, a mixture of lead and steel, for example, and your factory made 1,000 of these a day or an hour, how many, how much steel do you need an hour, for example? Calculate the volume, and then that would be a proper question. And that's why it's good to know these where you don't have the formula first. Okay. So yeah, then to calculate the volume, you can ignore the bit at the red bit I've added. So you just do 24 times x. So that's the volume. 24 times x. Centimeter cube, yeah. 144 centimeter cube, yeah. The next one, you need to so they've given us the area of the triangle. So remember, you could get a problem where they give you the base and the height. So again, in the first 28 slides that you've got there, I will send you, they show you how to calculate the area of a triangle if you've got the base and the height. Basically, it's half base times height. So area has been given times 9, so 25 times 9. This one should be 225 centimeter cube. And the last one here, calculate the volume of this hexagonal So 80 times 15, which is just 1,200 centimeter cube. So 3 easy questions there to answer, but it's good to know those because those are revision from Nat 4 and math. Nat 5 expect you to know everything that you've learned so far to get to this point. Okay. In this case here, instead of asking us to calculate the volume, they've asked us to calculate the height because they've already given us the volume. So you've got to solve an equation where volume 144 equal 18 the area times the height. So how do I find the height? What's the
Would you not
opposite?
divide the area by?
You've got you would divide the height by the total volume of the prism.
Yeah, the total volume by the area.
Yeah.
Ah.
So basically, to get rid of a multiplication, first of all, you divide. To get rid of a time 18, you divide by 18. Because that will become 1. And that's what I'm looking for. I'm looking for h on its own. And because it's an equation, remember, whatever I do on the one side of the equation, to keep the equation balanced, I need to do the same on the other side. And that's how you solve the equation. 144 divided by 18, which is 8 centimeter. So to get a volume of 144 centimeter cube, I need to make my height equal 8 centimeter. Okay? The next one is very similar. You need to find 40 length, so 40 L equal 1040. 1040 divided by 40 should be 26, hopefully. Yeah, so 26 centimeter would be my length. And the last one, I've got a volume, so this one is a square base. Calculate the length of each side of its base. Okay. So I need to find, so 12 times my area is 432. So I need to find the area here first. Yeah. So area times 12 equal 432.
Yep.
To get area, we divide by 12 each side. So 432 divided by 12 is 36.
Yep.
That's area of the base, so you would
So
divide that.
yeah, so that's this area here, 36. So that's not the question they've asked me. So 36 centimeters square. So the question is, what is the length of each side of its base if it's a square base? So this here length is equal to this length. So on a square, how do I get the area? If it's a rectangle, yeah, length times breadth, but because length and breadth are the same, it's just L square. Because you've got L here and L here. It's a square base, so all these are the same value. So 36 is L square. What is L?
Root 36.
Root 36, yeah. And that's how you find your answer. Okay. So have you noticed we only given the positive answer because that's the only plausible answer. The only possible answer is a positive 6. But mathematically, root 36 can either be plus 6 or negative 6. Yeah? But because we're looking at into context something that is a real value, you can't have a negative length. Okay? But just so that you remember. Okay, so if you want, we can take, yeah, we're going to take a 5 minutes break before we're going to start volume of a cylinder. Because after the volume of cylinder, then we will go into the volume of the NAT5. Okay, so 5 minutes break, and then we can come back to it. And we'll look at volume. So again, volume of cylinder, that's a bit of revision. Okay, so if we're back at 10 past 7, we should be okay. So we're going to look at volume of a cylinder next. So again, yeah, this is level 4. So you see it on the side. So a cylinder, like I said, it's exactly the same approach. When you treat it for the prism, we were looking for an area, and then we were timing by the length. So this time here, if the cylinder is positioned like this, it's just timing by the height to get the volume. So area time height, volume of a cylinder. So area of a circle, because it's a cylinder, so it's pi r square, so r being the radius. So remember when we were doing sector area, pi r square was for the full circle, and we used to do theta over 360. So if it's the full circle, theta equals 360. 360 over 360 is just 1. That's why it's pi r square times the height. In this case here is h. And you'll see it written pi r square height. So again, this is not in the formula list because they expect you to know the area of a circle. Okay, so in this case here, I've got find the volume of the cylinder. The question was asked to give the answer to 1 decimal place. That means we're gonna have to use a calculator when it comes to that type of question. So pi r square h, so you take your calculator, 25 times shift to pi, so shift x 10x time 10, and the answer is 250 pi, which is 785.39. And if you round that to 1 decimal place, you get 207.85.4 centimeter cube. So just those steps to type in your calculator. And that's how you calculate the volume of this circular prism or cylinder. So I'm not gonna go through these, but what we'll do together, we'll do the last 2, because the others are just, you just use the pi r square times 10, pi r square here times 5, and pi r square times 18. So let's have a look at more of the problem solving one. So the first question I've been asked here, I've got 2 cans in this cylindrical form. So we've been told that they can be filled with soup. Which one will hold more? So how do you do that?
You want to find the area or the volume of A and the volume of B.
Yeah.
And then
Take the biggest away from the smallest.
do the big, yeah.
And
all
see
that.
which one is the biggest, which one is the, okay.
Yeah.
So on you go. How will you calculate volume of A?
times pi 6 squared
Yeah, so pi 6 square.
times the height, which is 7.912. I haven't got a calculator, it's in a box somewhere, so I'm using my phone. Apologies.
That's okay. Times
We'll do
7. So then I can do the same for the other one. I can do pi 10 square. And without a calculator, I can probably see which one is bigger. Because pi 10 square times 10 is 1000 pi, yeah?
Mhm.
Because 100 times 10 is 1000. So here I've got 1000 pi centimeter cube. Because that could be a non-calculator question, right? 1000 pi centimeter cube for this one. And this one, I've got to do 36 times 7. So 36 times 7 is 252. Oh, sorry. I made
That's
a
5
mistake here. Yeah, it's 5. It's 25. That's 5. 25.
times 10 to
So 250 for this one.
50 times pi 785.
So 250 centimeter cube for this one. And 252 for the other one.
So see if you didn't have a calculator.
50 pi, yeah. Sorry.
See if you didn't have a calculator.
Yeah.
Obviously for a pi one, can you just put it as 3.14?
So here, because it's 252 pi, we don't need to even calculate. We can just answer the question by saying this is 252 pi, this is 250 pi, which is the biggest. So you don't even need to bother about using pi equals 3.14, if you see what I mean. You can see straight away that with this, you've got enough to give the answer. If they had asked us, calculate the volume to 1 decimal place or use 3.14, then you would do the extra work. But we don't need to do that extra work. If remember, what you're trying to do is try to get as much information as you can get, and once you've got them, make a conclusion based on that information, and that's enough. Okay.
Okay.
But you're right, it's very tempting to go, oh, I'm going to do all my calculation, and then, but I can see straight away 252 times 3.14 is bigger than 250 times 3.14. So then you would just say A will hold more because VA is greater than VB. Okay, so that's how you would answer this question. Now for question 5, again, these are revision type questions. This hot water tank has a diameter of 60 centimeters, so straight away R is 30, it's half, so radius is half 60, which is 30. So I'm putting what I've been given on my paper. It is 80 centimeter tall, so I've got a height. How many liters of water will it hold when full? So that you know, 1 centimeter cube equal 1, how do we say 1,000 in French?
So meal.
Mil, yeah, mil. So milliliter comes from the Latin word 1,000, which is 1,000 of a liter. So 1 centimeter cube will hold 1,000 of a liter. So you need 1,000 of those wee centimeter cube to fill in a bottle of 1 liter. Okay, so that's one thing. We've been asked to give it in liter. 1,000 milliliter is equal to 1 liter. So once you've got these two, now you can calculate the volume of this hot water tank in centimeter cube, and then change it into milliliter first and then to liter. Okay. So find volume in milliliter first. They've even given us that. So we would do pi r square times 80. So pi 30 square. You can use a calculator on this one. It tells us on the top left here. Time 80. So that's my volume. So shift the pi times 30 square times 80, and I get 72,000 pi, or 226,194.67. So that is centimeter cube or milliliter. Now, to give your answer in liter, because 1,000 milliliter makes 1 liter, you just divide that by 1,000, or 226, and we're going to decide to give it to 1 decimal place here. So 1 decimal place to liter. Okay. So and that makes, again, in context, something plausible. A water tank, a hot water bottle, for example, can hold about 220 odd liters of water. So if my answer was like 2 liters, then I would ask myself, there's somewhere I've made a mistake here, the question. It'd be quite, unless if it's a hot water tank for just making a cup of tea or cup of coffee or something. But usually they're not in that shape. They're a bit like the wee square ones. Okay, so that's how you would answer this question. So again, volume liters is important to know.
You need to know that prior, that 1,000 milliliters is a liter. It's obviously basic.
Yeah, 1,000 meter is 1 kilometer. 1,000 milliliter is 1 liter. The bit that you probably need to learn is 1 centimeter cube is 1 milliliter. Okay. And at primary, when we were in France, because we use Latin word, 1 decimeter cube is 1 liter. So that's another thing that we know, but I don't think decimeter is something that is used commonly in UK. They either use centimeter cube or milliliters. Okay. So let's check. Yeah, so it looks like here we got 226.2. They must have used 3.14 when they gave this answer there. So we're not going to do these. You can play with these. So now this is NAT 5, level 5 exercise. So we're learning how to use the formula for the volume of any pyramid and apply it to solve our problems, okay? So you don't need to know the formula. You can recall it from your formula list and apply it. So volume of a pyramid. So I've got different shapes here: a cone, a square base pyramid, a triangular base pyramid, and a hexagonal base pyramid. So you can see it's quite easy to get quite a few. So from the formula list, you've got V as a third of the area. So by area, they mean the base. time h, the height, the perpendicular height. So it's the height given from the top here of the pyramid right down, okay, the vertex they call it. So area of base, height. So let's apply that. So here we've been given this exercise, a height of 12 meter with a hexagonal base pyramid of 100 meters square area. So what is the volume?
Third times by 100.
So a third, yeah, time 100 time 12. So a third of 12 is
4.
4. 4 times 100.
400 milliliter, 400
Me-
meters. Millimeters cube, sorry.
Meter cube, yeah. So basically the volume is quite a big volume, but remember pyramids are usually quite big. So a third of 100, which is 400 meter cube. 4 times 100. And remember, you don't need to do 100 divided by 3 first. You do 12 divided by 3, much easier. Then you time it by 100. Okay?
Yeah.
Because this is a question that could be no calculator, right? Because they expect you to be able to do 12 divided by 3 times 100. 400 meter cube using your formula list. Now, in the formula list as well, we've got something called the volume of a cone. So this time, you've got your radius, the perpendicular height. The volume of a cone is again something quite similar to what we looked at the pyramid. So it's a third. But pi r square, obviously pi r square being our base. Yeah, circular base. So the area of a circle is pi r square times height. But again, this is given. So if the cone above us here has a radius of 15 centimeter and a height of 10 centimeter, how would you calculate its volume? So did you see this? Use pi equal 3.14. So that would be a non-calculator question. Okay, so how would you do that? If you didn't have a calculator, so 15 times 15, which is 225. 225 times 3.14. Okay. So let me think, what would be the quickest way to do this?
What would you do if you didn't have a calculator?
Yeah, so to be honest, with 3, a multiplication with 3, it's rare that you see it.
Yeah.
So yeah, I think, yeah, it wouldn't be that kind. They would be nicer, because what they would do is they would put here, you see where it says r square, they would have given you 15. But if you do 15 divided by 3, what do you get?
5. So
5. So 5 times 15. So you can do 5 times 3.14, for example. So 50 plus 25, so 75. 75 times 3.14. Yeah. So the way to do it, if you didn't have a calculator, would be to replace r with a 15 and divide. So you would do 3.14 times 15 square. So you would simplify that as a 5 times, you would do 3 and 5 times 15. Yeah, it would take you a while, but you'll get there. Okay. But yeah, 2,355 centimeter cube. And if they ask you if you turn the cones upside down, how many milliliters or how many liters of water could you put in there? You would divide that by 1,000 because that would be milliliters. So you would say 2.355 liters of water can be held inside this cone. Okay. So this is going to be homework 1. Let's have a look. So we've got calculate the volume of each of these pyramids. So we're going to do the first one.
Can you just go back 2 minutes just till I write down that?
Yeah, so 10B, question 1 and question 3. 10C, question 1 and question 5. And they are page 79 and 80 and 81.
Okay, that's fine, thanks.
So calculate the volume of each of these pyramids. So you would need your formula list. And we said it was 1/3 of the base area time the height, wasn't it? Volume.
Yeah.
1/3 of the area, the base area, time the height. So area here is 6 by 6, so that's 36. 36 divided by 3 times 7.
12 times.
Yeah, so 10 times 7 plus 14 basically. So 70 plus 14.
84.
Yeah. 84 centimeter cube. Okay, so area times the height divided by 3 based on the formula list. So they've told us here, be careful with finding the area of the triangular base in part C. So let's have a look at part C. So part B is here. You could do that. So part C is this one here. So you've got to find first the area of that triangle. To find the area of the triangle, remember the formula for triangle area is half base time the perpendicular height. So if I've got 5 here, I've got to go from there to there. So I've got to find this distance when I've got a right angle here. So I've got 2.5, which is half of 5. I've got 5 here. So Pythagoras tells us
Half the base.
5 square minus 2.5 square, and you square that and you get this distance here. So we're looking for that distance, right?
Right.
So to find that distance, you need to take the square root of the hypotenuse square, which is 5 square, minus one of the shortest side square. So that's Pythagoras basically. And that is this kind of height that I'm looking for. That is h. So you take your calculator, square root of 5 square minus 2.5 square, and I get 4.33. So 4.33 is my answer.
And then you need to times that by the height.
Times that by, not yet. Remember, we're doing, at the moment, we're looking for area of the triangle,
Ah,
of the
yeah.
base, area of that. So half, so A equal half of that, so times 0.5 time my base is 5 centimeter, and I get 10.825.
So 5.
So half, this is the base here, B, 5 centimeter equal B, so that everyone sees it. Half of 5 time 4.33, and I found my area 10.825 centimeters square. Now to get the volume, we're going to use my formula list, which tells me it's a third of area time this, we're going to call it capital H for the big H. So a third of 10.825 time 11, and the 39.69 centimeter cube. So if you put in your calculator a third time 10.825
9.69.
time 11, your final answer should be 39.69 with 2 decimal places. I can't remember if they ask us to give us to 1 decimal or 2. I can check again. Centimeter cube. Just to be safe, I'm just going to put, I've rounded it to 2 decimal place. Okay, so you could see how tricky this question was, because you needed Pythagoras to be able to calculate the area of the base triangle here, and then to use the formula list to calculate the volume of your pyramid. Okay, much easier if you've got a rectangular base, because the area is just length times breadth. Okay, so I'll let you do the other ones. And in here you've got a bit more complicated. But to do this, I'm looking at these. So you've got 1, 2, 3, 4, 5, 6 similar shape. So technically, if they ask us to find, so 6 identical square base pyramid fit together to form a cube. Yeah. So you've got the cube side 12. So if it's a cube of side 12, the total volume is 12 times 12 times 12, right?
Mm-hmm.
Once you divide that by 6, you get the volume of 1 pyramid. And you know it's a third time the height time the base. If it's a 12 by 12 base, then you know what the area is.
Mm-hmm.
To find the height, because you've got 6 equal pyramids here, that distance is exactly the same as this distance. So that means those are coming in at halfway through here. So the height of one pyramid is just technically half of 12. So it's half of 12,
6.
6 centimeter. So you've got everything you need. You've got the base, you've got the height. Oh, calculate the height. Yeah. So you need to calculate the height knowing that the volume is a third. So V equal a third of 12 cube. So 12 to the power of 3. Why a third? A 6. There's 6 of them, isn't it? A 6 of 12 cube.
288.
Yeah. 288 centimeter cube. That's the volume of one small pyramid there. And the base is a 12 by 12.
Mm-hmm.
Area is 12 by 12. That's 144 centimeters square. Yeah?
Yep.
So a third time A time the height, which is what we're looking for, equal 288. So times 3 divided by 144. Yeah, so to be honest, I found the answer even without going through all this work. Because now that I've got a third of 144, 144 divided by 3, that is
48.
48. So 48H equal 288. 288 divided by 48 now is my answer. And that
6.
should be 6 here. And remember I told you straight away it should be 6. If they are equal pyramids, then they would touch in the middle, in the center of your cube. So if this is 12 centimeter, they've got to touch at 6 centimeter. Otherwise, you're never going to be able to fit them all like this. So whoever put that problem probably didn't realize that you can deduce the answer without even doing all the math. Yeah, so this would not be a problem given during a proper NAT 5 exam, because you don't need to do any calculations to get the answer. Yeah?
Yep.
Okay. But you can see what they were trying to get us to do was to find the height by doing the calculation. But imagine if this was like 1, 2, 3, 4, 5 marks, and someone comes straight away and says, I can see this is 6 centimeter, because for them to be equally spaced within this space, you've got to be at half the height or half the side. So that person would, to me, would get all marks, even without having done any math. Okay. All right, so some other exercise. So you've got to use now the volume of a cone by using a third of pi r squared times the height. So you can just use those same here. This time you've got a height of 0.25 meter in this case, but here a height of 1 over pi. So 1 over pi is just a value again. So when I see something like this, because I know I need to time a third time pi r squared time 1 over pi, so pi divided by pi just becomes 1. So you don't need to do a lot of math. You can just simplify pi and pi. So again, another type of question that you just need to read through, and conical tip with a height. So, okay. So let's have a look. So you can work your way through these. And then the next bit is we're going to learn how to use the sphere formula in real life problem. Okay. So if you want to take our last 5 minutes break, then please feel free. I'm going to pause the recording just now. So yeah, we are looking at the volume of a sphere here. So first thing first is if you were to cut the sphere in half, you get a half a sphere. You can see where the diameter is and where the radius is, and the radius is just half the diameter. So once we've got that, the formula from the formula list tells us that the volume is just 4/3 of pi r to the power 3, or r cubed. And that makes sense because pi is a ratio, it's got no unit. R cubed could be a centimeter times a centimeter times a centimeter. Okay, so let's have a look. If the above sphere has a radius of 10 centimeter, can you calculate its volume by applying the formula there? So on we go.
I put 4,186.6.
Yes, I got.
Okay, so let's think about this. So I've got 4/3 pi times 10, 4,187. Yeah, sounds right. And this answer was given with 4 significant figures. Yeah?
Yeah.
Yep.
Using 3.14. So now find the volume of the composite shape here. Give your answer to 4 significant figures. So this time you can use your calculator. So whenever you hear this composite shape, think about splitting them into shapes that are more common to you. So the first shape, we're going to call it V1. So V1 is this shape here. Remember we did the cylinder today? So we need to calculate the area of that circle, and we're going to time it by the height. And they've told us the circle has got a diameter of 2 meters and a height of 6. So V1 is pi r squared times 6. So you can clearly see that you've got the two shapes there, cylinder at the bottom, half of sphere at the top. So cylinder pi r square times the height, which is 24 pi meter cube. For the sphere, this time is half of a sphere. So instead of 4/3, it's half time 4/3. Half of 4 is just 2. So 2/3 pi r cube. So half a sphere is half of 4/3 pi r cube. So 2 times 2 times 2, that's 8. 8 times 2, 16/3 pi. So we've got V1 and V2. Now the total volume is just you add V1 plus V2. So 24 pi plus 16 pi/3, and that gives us 88/3 pi. And if you type that in your calculator, 88/3, shift the pi, the answer I get is 92.1533. So 4 significant figures, we stop after 2 decimal places. And because the third decimal place is a 3, it's just rounded to 92.15. Okay. So in context, you could have something like this. We've got a dome of some sort, and you've got to split that in two to calculate the volume. Yeah. So what was the biggest difficulty here would be to find that it's not a full sphere, it's half a sphere. I would say to me that's the bit that was tricky for some, and noticing that if you've got 2 meters here, when you calculate this from the center to the top, you've got a radius again of 2 meters. That's why here pi r cube is pi times 2 to the power of 3. Okay? Because if that is 2 meters, the radius is going to be 2 meters all around. Okay, so you've got question 10A and 10D on the Leki. Question 1 and question 6, question 1 and question 4. Page 77, 78, and 82. And we're going to go through a couple. Just to practice. So this, to be honest, there's not much lesson involved into it. It's more how to use the formula list and practicing with a few examples. Because the formula are given anyway. Okay.
Yes, thanks.
Let's have a look. So you may use a calculator for this exercise, and you should round your answers to 1 decimal place unless otherwise stated. So in all the 10A exercises, they've asked us to give it to 1 decimal place. Calculate the volume of these. So you open your formula list because they've told us these are spheres. V equal 4/3 of pi r cube. Yeah.
Yeah.
So let's do, this is A, B, C, and D. So let's do C together. So V equal 4/3. I'm going to use my calculator. time pi time, what's R?
4.5.
4.5.
Yeah. So that was the only difficulty for this one, is to know that you've been given a full diameter. So calculator out 4/3, the fraction, shift pi time 4.5 cube, and our answer I get is 381.7, 1 decimal place. And these are centimeter cube.
4/3 times by pi times by cubed.
Yeah, so make sure when you put it, yeah, you use the fraction 4/3, then shift pi time 4.5 cube. That should be a positive answer. So again, the rest you just plug. It's a bit substituting R with 7, with 12, with 0.1. In this case, we've got a 0.25. Again, this is not the radius, so you need to watch. And the last one in our list was a 2.5 meter. So you've got quite a few to practice with. Okay. So the next question is a problem. So I've been given a spherical ball which is dropped into a cylinder of water. Calculate the rise in water level if the sphere has a radius of 4 centimeter and the cylinder has a radius of 7. That was for A. For B, the sphere has a radius of 3 and the cylinder has a radius of 4. So we are asked to calculate the rise in water level. So I'm going to pause the record. So yeah, 268.08 if we want, we can put that 2 decimal place, 268 after calculating the volume of the sphere, 0.08 centimeter cube. So now what you need to think is, before putting that sphere inside, the volume was somewhere here, right? We've added the n and the water rose by this height. So that's the question they've asked us.
What's different, really?
But the height is this, basically that height is proportional to the volume that has been added. So the volume of water here that went up by is exactly the volume of the cylinder, because we've just put it in. Yeah? So this volume of this part of a cylinder, so now we've got, yeah, the volume of a cylinder we said was pi r square time the height.
Yeah.
What is the r?
7.
For the sphere is 7. So 7 times 7 is 49. So 49 pi time the height equal 268.08, because that's what we put in, and that's how much the volume increased by. Now, to get rid of 49 pi, you just divide by 49 pi both sides, and that gives you, that will give you the height. So 268.08 divided by 49 pi,
1.74.
1.74 centimeter.
And that would be the difference in
Yes.
height.
Yeah, so basically we went from whatever the height was, and that rose by nearly 2 centimeter once we dropped the ball in. And that was the question they asked us to answer in A.
It's actually so simple when you actually think about it like that. But
Yeah, so you need to kind of visualize what you've been given. Okay, so by giving you a sphere as well, so you know you're gonna have to use to calculate some sort of volume of a sphere, but then you've got to put in your head that whatever volume you've added in is going to be the rise there in the water level. But then you need to know in a cylinder, how do we calculate the volume of a cylinder? Or how do we calculate the volume of this cylindrical portion? It's just pi r square, so you've got your r here, which is 7 centimeter in our case here for the cylinder, time the height, which is exactly the volume of the sphere that been added. So that was A. For B, you do the same, but this time they've changed the size of the ball, but as well, have you noticed they've changed the radius of the cylinder as well. So they made a smaller ball, but a smaller cylinder. And then you can calculate what is the new height, and that might give you as well, okay, an idea. By making the ball smaller, but by making the cylinder smaller, maybe the height will get bigger. Okay, and the good thing about these kind of exercise, if you get it into a class and you want to work with them, you can get a couple of different bowls, like marbles, for example, and take a couple of different beakers or tube, and show if you measure it by how much you would go. So you could now do it in practice. Fill your beaker with water, measure the height, measure the the diameter of your sphere or your marble. Same thing. If you think one is not enough, you can tell them, okay, let's put 10 marbles. So you calculate the volume of one, you time it by 10, you drop them in, and you can now say, okay, let's measure the height. And you can now tie in what you've done mathematically if it matches with the reality. And some visual student might be able to see it better that way, and next time they get a problem like this, they'll see exactly what they've been asked to do. Okay. So in this exercise, what we've been asked to do is this toy is made from a cone of a height 12 centimeter attached to a hemisphere, so half of sphere with diameter 8 centimeter. Calculate the volume of the toy. So basically, again, you've got two parts, half a sphere and a cone. You look at your volume of a sphere, volume of a cone, but for the sphere you take half of it, and you do all your work in step by step, and you add both, and that's you. You should have the volume of the toy.
It's a funny looking toy.
So it's one of those, yeah.
Maybe a
How
rattle.
do you call it? The one, yeah, that you
Oh, you
spin
spin.
the spinner, yeah.
Yeah.
And 12 centimeter, that's quite a decent height. 8. So it's about, yeah, it's about that size. So you could see that physically something like this would be something. Okay. So again, yeah, split it into composite shape, they call them, and walk through it. using the formula. Again, this is very much, we've done an exercise that looks like this. So you've got a cylinder at the bottom. So a grain store could be like this with a dome, hemisphere. So hemisphere just means half a sphere. Calculate the volume of the grain store if it has a diameter of 6 meters. So you've got a height of 8 here. So usually this is what you would do when you get something like this. You would start putting what you've been given. So 8 meter. And they've told us diameter is 6. So you just go, this is 6 meter. And because I know I'm working with cylinders and stuff, so then that is the radius, which is just 3 meter. Half the 6, right? So calculate the volume of hemisphere plus cylinder, pi r square times height. The hemisphere is 4/3 of pi r, or pi r cube, yeah. But divide by 2. And then that's you. You should get your answer. And then after that, so these are 10D and 10A. After that, basically, you just got a few practice questions. So we'll do a couple of them, and then I will let you go. That means you can do it yourself and work through. So let's work with this one with liters. I like it because when you do science, you'll find out everything gets changed into milliliters and liters, which talk more to us, because when you drink something, you don't say, I'm going to drink a 500 centimeter cube of a drink. So lemonade is to be poured from a 2-liter bottle. So straight away in my head, 2-liter bottle, that's 2000 milliliter or 2000 centimeter cube. So I'm putting that on the side. So 2000 centimeter cube. I'm putting that in centimeter cube because I can see question coming with glasses that are 3 centimeter and 8 centimeter. So I would rather work with all the same units. When I'm talking, do you hear me being cut, or is it okay? I just got a message telling me that my internet connection is getting a bit poor. Can you hear me properly, yeah?
That pausing there.
Oh,
Yeah, I can see. So, yeah, 2
probably 'cause
liters.
it's chucking a rain outside.
Yeah, okay now, yeah,
Yeah.
but you were coming and going.
Okay. So 2 liters is 2000 milliliters. And remember what we said, 1 milliliter is equal to 1 centimeter cube. It looks like I got dropped. Are we all back? I wonder what's going to happen to my recording.
It's still recording.
Oh, it was still recording even when I dropped?
I think so.
Yeah.
Okay.
Can't still back me up.
Yeah.
So I guess I need to reshare my screen then.
Yeah.
Yeah.
Okay. Yeah, for some reason I just got cut and he asked me to rejoin. So if it's still recording, that's okay then. So what I was saying is I would change, because everything else is given with centimeters, and I feel more comfortable giving my volumes in centimeter cubes. So I changed straight away my 2 liter into milliliters to start with, and then milliliters is in centimeter cube into centimeter cube. So how many full glass can be poured from the bottle? That's a good question. So I need to find the volume of one glass. Yeah. So a glass is this shape. So that's cylindrical. Yeah, a cylinder.
R
So
squared.
pi r square time the height.
What in height?
So pi time 3 square time 8 is the volume of a glass. So if you want, you can just put V with a small g or a g there, so you know what you're doing. So pi time 9, so 9 pi time 8, that is 72 pi, which is 226.19. So 226.194, we're just going to round it to 0.19. So now I take my 2000 centimeter cube and I divide that by 226.19. So 2000 divided by answer. So this is where if you don't want to round anything, you just do divide by answer and you hit equal and I get 8.8. So how many full glasses can be poured from the bottle if I got 8.8? So look at the question, full glasses. So my answer was 2000.
Glasses can be poured.
So 2000 divided by 226.19 was 8.8.
Yep.
So how many full glasses can we pour?
Is the answer not only 8 because you can't pour an 8.8 glass if it's a full glass?
Correct. So you'll be able to do 1, 2, 3, 4, 5, 6, 7, 8. So 8 full is your answer. And the other one will have 80% inside it. So that's not a full. Okay, so you only put 80% in it, 0.8. So answer is 8. Okay, so you can see if someone doesn't know that 2 liters is 2000 milliliter, 2000 milliliter is 2000 centimeter cube, the person might be struggling to be able to answer this question. Okay, so the next question, the side length of a cube is 2x in centimeter. The expression for the volume in cubic centimeters is equal to the expression for the surface area in square centimeter. Calculate the side length of the cube. Okay, so let's pause this and try to read. First thing first, volume in cubic centimeter is equal to the expression for the surface area in square centimeter. So what's the surface area? That is the surface. 2x by 2x. So basically what they're telling us here is 2x cube equal 2x square. Do you agree? Volume equal. Calculate the side length. So we need to solve this in order to get x, because the side length is just 2 times x. So how do we do that? You just go, I'm going to put all the x's on one side. So 2x cubed first. What's 2 times 2 times 2?
It's 8.
Sorry, 8, yeah. 8x cubed. That's the first one. If I want to move 4x squared on that side, it just becomes minus 4x squared, yeah?
Mhm.
Now you can solve it.
And that is equal to, if I take away 2x squared from each side, 2x squared minus 2x squared is just 0. Do you agree?
Mhm.
Yeah.
Now that we've got that, we've got to factorize. So I've got x cubed and x squared. So I can say that I'm going to get x squared out, my factor. And I've got 8 and 4. The
You
highest
take two
common
out.
factor, is
4.
4. So 4x squared times 2x minus,
X.
X.
oh, I've got 4x squared. 4x squared times what? Give me 4x squared.
1.
Yeah, times 1. Because if you do x, it's going to be
Yeah.
4x cubed
Yeah, you can't do that.
equals 0. So I've got two factors. Something times something else equals 0. If one of them is 0, that will work.
Hello.
Can I have 4x squared equals 0 though? 4x squared can't be equal to 0 because if 4x squared equals 0, then that means x equals 0. And then 2 times 0 is 0, so you've got no cube. So it's got to be the other one. Yeah? So then that means 2x minus 1 equals 0. Now you solve this. How do you solve 2x minus 1 equals 0? Get rid of the take away 1. What's the opposite of taking away 1?
Yeah.
Adding 1.
Adding 1, yeah.
On the both sides.
Both sides. Then that means I've got 2x equal 1. And what's the,
Hello.
can you hear me?
I think we've lost him. He's back.
Have I lost someone?
Yep.
Let me check.
Yeah, you're coming and going, but
Yeah.
yeah.
Yeah, the connection is not the best today, by the look of it. So if I've got 2x equal 1, the opposite of timing by 2 is just divide by 2. Then that means x
No.
is just a half. So x equal a half. Now, the question was the side length was 2 times a half.
1.
Yeah, so 2 times a half is just 1. So the side length is 1 centimeter. So 2 times a half equal 1 centimeter. Now, do you think I would stop here? I'm just going to reread the question and see if I can check that 1 centimeter makes sense. In order for a volume to be equal to the surface area, 1 times 1 times 1 is 1 centimeter cube. But 1 times 1 is 1 centimeter square as well. So you've noticed that with 1 as a side, the area of 1 centimeter square, the 1 is equal to 1 centimeter cube. The 1, okay? And that means I know that I've got the right answer because I've quickly checked it, that 1 centimeter cube would work with 1 centimeter square. Okay?
Yep.
So this is what they were trying to get through this problem. But you can see with volumes, you've got areas, you've got a bit of factorization, you've got a bit of solving an equation. So you can see within a problem, you've got a bit of fractions come into play. Timing a fraction, you can mix quite a few of some of the skills that you guys been learning. Okay?
A lot of work to isolate x, you know, and terms of finding sigma.
Yeah, so you needed to factorize here.
Mhm.
That was the main, I think,
Yeah.
issue here, is to be able to know that if I've got something like this, I need to factorize. How do I factorize? And maybe as well writing this.
Mhm.
So the variables here was the expression of the volume is equal. So I'm just saying volume equal to the expression of the surface. So once I've expressed that, now I can see what they're trying to get me to do. Yeah?
Yep.
Okay, so in this, I'm going to send you this, so you'll see there's quite a few other questions. So if you want to practice some of them, or if you get stuck with one of them, you can let me know, because these are all questions that are could be hit into a NAT 5, but they were level 4, some of them. So some of them you might find easier than others, but it will get you to revise some of the NAT 4. Okay, skills. I think I'm gonna stop recording from now.